Alright people, just reach home. I have to go back and get some camera stuff from church. That took me some time. So we are a little late. What's the time? 5:22. We'll see what we can do. Well, you know the drill. Press like. I guess there'll be some last year people on this stream. So press like. Now keep in mind, what I major on is my, like, you know when you're playing an RPG and they say what is it mean? My main is CSEC maths, ad maths, and pure maths. That's what I teach in school lessons professionally. But I study mechanical engineering and physics just really comes naturally to me. So, and I used to teach Cape physics as well a while back. I taught some people who, one of the people I taught went on to get either an open skull or an open skull. Let me just be safe and say open skull on the Cape physics. So I'm pretty good in the Cape physics, but just like if I had one day to do it, I could do it in one day and probably get back a 1. But if I have to teach it like how I teach maths, how you all are accustomed to teaching maths, chemistry, physics, something off the top of my mind, I need to revise to know the terms, to know what to look out for. Then I need to do lots of papers and practice and that kind of thing, just to understand what really going on in the curriculum, what really is the vibes now. So I don't have no time to do that. So you'll getting learn as we go along kind of thing. You'll get to see how I would figure it out. That you also I don't know if I'll finish the whole thing today, like I didn't. I remember there because I was reviewing this entire thing the whole of last night. Simple harmonic motion, angular velocity, angular frequency for simple harmonic motion, angular frequency. Just them omegas and Snell's law, this, that, the other. I reached down to the end. I unraveled everything to the end and it's a little jumbled up, so you'll see some stuttering. But I hope you all would appreciate this and I know it will help a lot of people. So let me see what's going on here. Javette. Hey, Javette, that was the scene. Brian, Kyle, Medina, I know Kyle long time. Anil, DJ, Anil. See. CSEC physics, yeah, we'll come through that. CSEC physics is cheese, it's cooks and cheese. I kind of underestimated this, but I say I just do it in one night and be able to teach it from the top of my mind, but snap. Still I have some textbooks, something in standby just in case now. We need to rip out some formulas from something. 2018, alright, we'll see. What I will do is after this live, I'll post something someone sent me a solution sheet on my Instagram. So, and the solution sheet looking legit. It looking legit. I really see no errors in the solution sheet. Okay, so that's enough talking. Whoever watching this video back will have to skip all that first 5 minutes. Good luck with that. Answer for number 1. Press like, share the 52 likes, 130 viewers. Close off the live chat, press like, bring back up the live chat, let me make the thing look nice. Or you're not new. There are no new people in this. I doubt it have any new person in this live. Lasso measure the ring light of radius 5 centimeters with a tape and gets now questions that people send me that is just like straight up CXC questions. I can't. We going through that. We going through and looking what's it looking solid CXC. Yeah. We can go through that on the channel. But what I have here will prepared, which of the following can be deduced about his results. Oh, so there's the precise accurate thing. Everybody's saying, hey, I need a calculator there. We need pi in the dance. Now let me see if I can bring up a calculator. Zip this up. I like to have a real calculator nearby any time and I drag this card. I don't know what my son also loves my calculator as well. So I must be doing what I want. So this precise thing by how it works. This is the actual value. Precise can be wrong. Could be, you know, like this. But not precise, but it's not accurate. This is like accurate because like the average of all the values on point, when not precise, it's scattering. Oh, blocking the calculator, bring up the calculator to block. All you understand this precise accurate thing? Anybody here who didn't, like, I mean, like the first thing you revise, this first thing, I think this first thing, right, that they bring on the, so if this is like your value, your actual value, accurate mean you're getting stuff on the value, but it don't need to be precisely on the value, just like your average values are. So how do you get inaccuracies? What kind of error? What kind of error? It coming back. What kind of error brings about inaccurate? And how you solve those errors? Or you forgive me if I use all the correct things. What kind of errors give you an inaccurate value, and how do you solve those errors? And what kind of errors give you a not precise value, and how do you solve those errors? But anyhow, this is 5 centimeters, this is 31.41 centimeters, or this is a given. Right. So we can work out the real thing now using, let's find circumference 2 pi r, right? 2 pi r. So we get them, I just do unit of calculator here, right? Let me just show you. 2 pi r was 5. And if that go work? Nah, they don't like it, so don't do that, they say. 2 pi 5, 10 pi. Ooh, that's so enlightening. 31.4. Hey, this man was accurate and precise. Hey, he only this is an easy one. This was an easy one. Parallax error, random systematic errors reduce accuracy. That is correct. Random errors reduce precision. That is correct. That is correct. No, I'm still feeling a little sus about that. What's in there? Random errors reduce precision. Systematic errors reduce accuracy. Very good. Yes, that's right. So how do you get rid of systematic errors? You fix the system. How do you get rid of random errors? Well, you can't get rid of random errors. To help random errors repeat. To help random errors repeat, right? Ding 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 ding. Or uncertainties. Random uncertainties by repeating, and systematic uncertainties. You switch the system, you fix the system, you fix faulty instruments, that kind of thing. So keep in mind they can access any one of them, anything along that line. And they could also access graphs, like maybe you shoot out a graph like this or something. I tell you, the real thing is here, and there's the values there. I understand? I feel like I see this in my exam back in the days. So, like, this is your distribution of readings. And let me say this is the real reading. I hope I'm not doing easy things here that everybody know and I'm just wasting my time here. I'll start to go forward. But I also just kind of revising as we go along too. This here is precise and accurate, But if I had something like this, it's accurate but not precise because it's spread out, that kind of thing. Feel the vibes, feel the vibes. So let me move forward. What else we have out here? Number 2. Let's get number 2. Right, so Nalene giving me a little advice there. How I remember which is which, I spell precision, the R gives me a sign that it deals with random. Right. How I remember which is I just remember exactly what random errors is about. Random errors, you can't fix that. I just think they're popping up. So that will affect the precision. If you can't fix it, it will not affect the accuracy. I don't know, that's just how I remember it. Oh, 208 viewers. All you don't forget to press like. I find the viewer ratio kind of off. All you need to fix that. See people saying one student recorded right, so they can give you this, like something is this and something is that, so equate them. It's maths. But what they're testing you here is on, like they might get pico or milli or micro or anything, kilo, mega. So you need to know all their prefixes. Right? So make sure you know that. All the time with them prefixes there, I think micro is 6, milli is, right, that's negative 6 to the power, right? 10 to the power. This will be negative 3. You have the thing, whatever it is, the thing. Then you have kilo. You have mega. Yes. But you have in between too. I think you have pico. I think it's pico. It's just a P. Anything else I'm missing out? Well, you know you have centi. That's the 100. That kind of thing. Alright, let me see what's going on here. Some people saying see some next. People not sticking. Oh, I'm thinking like maths here, but it's actually stars we have in the dance. Alright, A 3 milligrams, 3 times 10 to the negative 3. 9 times 10 to the 3. Which one are we making the subject? B. So B is the big boy. How many A's in B? Well, 3 into 9, 3. So yes, all of them have 3. And how many times can this go in that? Well, 6. So 10 over 3 divided by 10 to the negative 3. That's a big divided by a small, so you're going to get even bigger. So add powers, 6C. Alright, so what is this testing? This is testing units, and if you can play around with indices well. So make sure you know how to divide indices, make sure you know how to do units. Why is in the chat if all you're going to do that? Brian is giving us the next thing here. I get excited when I see his key, but I realize it's physics, not chem. Chem, I'm too sure if I can pull off the chem. Although after doing keep, I taught way more chem than physics. But physics is just something that is like riding a bike. I don't really forget the vibe of physics, like the understanding part. But chem is a lot of memorizing for me. It doesn't just stay. So like after 2 years, 3 years of not doing any chem, I'll have to go and read over some stuff. At least keep chem. Let's get the answer for number 3. Now, I'm not too sure what's going to happen. I'll even going to be the guinea pigs on Wednesday to see how much of the themes of the question they're going to repeat, or how much of the exact question or CSEC with the exact question they're going to repeat as well. This is our next easy question. 3 easy questions to start with. 1, 2, 3. This wasn't that easy. Well, yeah, this was easy. Everything was easy. This one could I get confused a little bit. This is easy. That is the resultant force, but you need to take this and send that across here. That's how we normally do it, right? So it's like this is a 5, 12, 13 triangle, but you didn't even need to know that. Oh, it just had one thing there, 13, going in that direction, 13, 3 marks. So 3 marks if these kind of questions come, 3 marks. 3 out of 45, boys. Let's tell me what percentage that is. We out there, we out here. Anything to talk about the resultant forces? Just resolve the forces. It could get a little more suspect, but I don't know if that could come in the multiple choice. Like they could give you a force like this and like this, and then you need to get horizontal components and vertical components of each of them. And you just need to remember, like if the angle is with the horizontal, then the cos will give you the horizontal and the sine will give you the vertical. Cos adjacent, sine. You know what I'm talking about? Why isn't it if you know what I'm talking about? Sine will give you the vertical component of each force. So like if they say this is 13 and this is 30 degrees, and if this is, I don't know why I use back 13, let me say this is 10 and this is 45 degrees, you should be able to determine the resultant force and the direction of the resultant force here. To pull in a multiple choice, if I was teaching physics as like with maths and thing, right, you ought to know what kind of thing they could bring in a multiple choice. But I guess they could probably test part of this concept somewhere. So if you have to do this, you'd find like the vertical of each forces, add them up, the horizontal of each forces, add them up, keeping in mind that whatever value here is negative to this value there. And you're using SOHCAHTOA. This one is Pythagoras theorem, straight up Pythagoras theorem, because they are right angles, form a right angle triangle. Alright, enough of that. Zoop. There you go again. Another question. To determine the density of a wooden cube, Frankie uses the formula rho is equal to m over s cube, and the result of his readings were side of the cube, mass of the cube, plus or minus. So this is the uncertainty, the error. What is called that? Error or uncertainty. There's a way we add up these things when you don't addition here. So if it's like straight up addition, m and n, straight up addition, add the absolute values of the error. When it's multiplication or like to the power, this is multiplication because this is s times s times s. You add the fractional like this, 0.1 over 7. So that's where you're adding up. Now keep in mind we have 3 of this, so you're going to add 1, 2, 3. So what we normally do back in the days, well, obviously they're doing it now too. You just put 3 times, what is this? 0.1 over 7. Brian wrong? Who's Brian? Absolute uncertainty. Some people say absolute error, some people say absolute uncertainty. I guess it's interchangeable. Over 7.0 plus this error now 0.5 over that. 0.5. You know this values just give you the answer for the percentage one time. I mean, they don't give you the answer for the percentage, they give you a fraction. But you can just multiply by 100 and that is the percentage one time. So whatever we get here is going to be the percentage error. So it's not like you need to put it over something and then, no, you just multiply by 100 one time because you're already getting a fractional value here. 205.8. So you hit them down your calculator. Everything seeming legit. Now just because this dividing don't mean you're doing anything special. Every new thing you put in, whether you just check it to see is multiplication or division or addition. If it's multiplication or division, add the fractionals. If, a next thing could come, you could get like A plus B. I'm just making up a formula, right? So if you have an addition inside of like a multiplication, well, you know you're adding up the fractional here, but you want to create the absolute value of this first, the A plus the B, and then use it as a fraction. Keep that in your back pocket. Wise neat chat if you understand that. This is just revision for some people. I'm using my calculator now. I don't think I need to show you all this. 0.5 over 205.8 plus 0.3 over 7. I get in 0.045, which means 4.5%, which averages to C. Yeah, I guess I'm averaging in K. I'm going to leave for CSEC, you get exact values, but I guess wrong enough is a skill expect you to have luck. Nice. Somebody don't understand, or they don't understand. Maybe I should give you a question then. Alright. Making up things out here, people. Now you say I have A is equal to 99. I use some solid numbers. 80 plus or minus. Normally we like 80.0 plus or minus. Let me make this right. 0.5 and forget the units you need to care about. Hey, hold up. No, you don't need to worry about units in this case because you're putting a fraction. So it's a ratio. So it's centimeters over centimeters cancel. You don't need to worry about units here. But like if you're using the whole total of something, then you need to study the units. But like if you're just working it out like a fraction like this, the units cancel it, so you're safe. Anyhow, B, I'm just making up a question here now. 50, alright, you say 5.0 plus or minus 1, 0.1, sorry. And like you say C is 400 plus or minus 1. And I say to get the percentage error in this situation. Hit me, get the percentage error in that situation. You all know how much time I get the question, which here is this. I'm not going to do a CSEC past paper on my channel. Yeah? Right. So, but what I'm giving you here is good stuff. A lot of people send me questions, but I can't 100% say that is not CSEC, so not CAPE, so I can't really use the exact thing that they send me. Anil is right. It is the error over the actual value. Cool. Whoa. I guess it's like the first thing they teach you as soon as you jump in physics and you start. I feel like I start teaching CAPE physics again. I don't like not being in the know of what is going on in CAPE physics. This little revision session for the weekend here make me return to my first love, physics. Alright, so we're gonna add these solely as first, you know. So this A plus B. Now if you're adding two quantities like this, it would suggest that they are the same units. Like if this was centimeters, this had to be centimeters too, otherwise you have no business just adding the two of them just so. That is not his work. You can just add centimeters and degrees Celsius just so. So it'll be like the same thing that they're talking about, right? So A plus B. So what I will do is add up these errors and add up this total score. I hope that is the correct thing to do. That's what I'm feeling like in my in my memory. So I'll you correct me. 85.0 and plus or minus 0.6. That making sense. So yeah, that score 85.0 now, that is all the value, that is the weight of the value that is carrying. And you have an absolute error that can range between plus or minus 0.6. I don't care, that had to be the right thing. So now the fractional error will be like 0.6. I'm making up my own thing and saying fractional error. I hope that is a good term to say there, but the fraction, right? So you're putting the fraction all the time. Why am I getting this fraction is because this is now dividing by that. So anytime you divide or multiply, you start to go into fraction land. And you're adding up that with c squared is 1 over 400, but the square is like 1 over 400 plus 1 over 400 because I like c by c. So what we do is put 1 over 400 multiply by 2 and we get something there. So this is like substitution. Okay, if you want to call it substitution, but you need to know what to substitute. So all textbooks will have examples in this, you need to just practice them. Practice. They will give you an equation just like this or something. An equation like this. Give you the readings, give you the errors. This is one way this thing question could come. They will definitely put a square or a cube just to see if you know what to do, what happens. If it's a cube, you multiply by 3. Or you just add it 3 times. And then you'll ask you to find either the percentage error or some kind of thing. Absolute error, whatever. If you have to find the absolute error, you just multiply it by the, remember, the fraction is a fraction of the whole value. So if you had to find the absolute error for this one, the fraction that you walk out with here, just multiply it by the total of everything. The final reading then, the final result. Just multiply by the final result. The answer that you got when you use the values in there. Anyhow, so let's go ahead with this. I'm getting 0. No, this is the last thing. 0.6 all over 85 plus 2 over 400 or 1 over 200. I'm getting 0.012. That's like when I multiply that by 100, that's going to be 1.2% thereabouts. So most people get that 1.2%, 1.21, yeah, 1.21%. So why isn't the chat if you're feeling good about that? And I'm saying if you want to find the absolute, if they're asking not for the percentage error, right? If they're asking for the absolute error, you go ahead and substitute these values, 80 and the 5 and the c squared, what do you have a c squared? Oh, this is going to be some kind of ridiculous thing. 400 squared, this is ridiculous, some small value, right? Whatever value you get here, now you say your x, just multiply by the fraction and that will be the absolute. Now you plus or minus now. You put plus or minus, this multiplied by that will be the plus or minus you put in there. Why is in the chat? Next question. So that is how this error thing does work. If anybody come and ask what year past paper it is, just give them the whole shout out to carry and read. Just give them the whole rundown. That we don't do that over here. We don't do past paper. We don't do multiple choice past papers over here. Here reports of lots of drives and things coming down. So it seems like CSEC team is trying to clean up their act these days, but the horse is already out of stable in most situations, if you know what I'm talking about. So, but we'll see what happens in the exam. As I said, this group of people who do the exams on Wednesday, you all are the guinea pigs. You all will see how the thing feel. Are they going in? Are they going in first? Back to Lasso. Lasso discovered the following equation: y is equal to k. Alright, so they always testing you on logs. Since my days, they testing you on logs. They must test you on some kind of logs. They will either test you on y is equal to kxn, something like that, or maybe e to kt or something like that. ekt y is equal to that, or ek, and they put the x up here. The x is the one you want up there now. So make sure you know how to do that. Now in the paper 2 you actually need to, I think like question 1 or something is be like you actually need to convert, you need to use logs, create your graph, get your values, get your gradient, get your whatever. But this is just asking you how to find the gradient and the y-intercept or whatever, how to find it, and you just take logs on both sides and know how to take logs, right? So log y, which one are we using? Log, normal log, is equal to log of kxn. Now the rules of log says that when you multiply, add. So product, right? So log of k plus, don't try to pull down the n first, eh? You need to pass up that action there first. Log xn, log y. So now this is like log y is equal to log k plus, why do you know all of this for? Why I feel like I didn't answer the question already. N log x. So you need to compare and see which one. Y is equal to mx plus c. There's a constant. This is a constant as well, m. Log x is the x and log y is the y. Y is in the chat if you understand that. So this means you're plotting the graph of log y versus log x. See, it doesn't always just be log y versus log x or log whatever. Like if they put p here, it doesn't always be log p versus log x. So sometimes it could be different. I think I'll put that next question, that could be different. Cakewalk. Nice. So some people have the straight line equation, ting, back. Some people call it the straight line equation. What country says straight line equation? We say equation of a line. Anyhow, close up that. Next one. Right, so I made an next question where you'd be forced to take natural logs, but I didn't write the answer in natural logs. Now, why did I not do that? Yo, this is some failure on part here, but I'll understand that I really start like around Saturday, come up with all these questions, look at a whole set of students submitted questions, real thing. So no sleep. Team no sleep. And I really look to do after this, and then I'm doing the next live for the CSEC math students. It's just fun and games. Frankie discovered the following equation: y is equal to aex. So you're doing the same thing, but this time it's natural logs. Ln y, so Euler's number, ekx. Separator, that's only a ln of a ln plus ln of e to the kx. Ln y is equal to ln a plus, what are we gonna do? What are we gonna do, fellas? Ln ex. Well, you see, the thing is, when you have the kx here, right? Ln e. Right, they like e to the 1, right? When you have the kx here, and you have ln of e. Ln of e, if you put ln of e to the 1 in your calculator, you're going to get back 1. So this is actually ln y is equal to ln a plus kx. So X Nyman by himself. Hey, I need to make some people I know here admins. Let me see, who do I know? And it is an admin, brother. Because sometimes people just jump on from wherever and see one random things now that we really don't want to hear. If I see anybody else from my classes, I'll be an admin. Right? So the answer is indeed D. You're looking at, I'll just verify any calculator so it will stick. I know when you see things, it stick a little more. If they give you an equation, keep in mind it wouldn't be y and a and e and k and x all the time. It could give you other things. The fact is ln of e to the power 1, which is like ln of e by itself, is 1. So we could just ignore him. Boom. Excuse me. Why is in the chat? Will you get through? You understand? I feel like we reached quarter of the way already. 6 questions done. I wish I had 100 of these questions. I could give you, if I cover 100 questions, like I cover every angle. Between today and tomorrow, I might cover about 50 questions. Let me get some answers here. You can't use log because it wouldn't get rid of the e. You end up with log to the base 10 of e. Now if you have log to the base e, well, there is ln. There is natural logs. So if you use log, you can't just, I mean, between me and you, nobody going and see that you use log and you forget to use ln and you cancel off log e. But cancelling off log e is not mathematically correct. And all the answers should be in ln if you have to use them. Sometimes with this, the question we do before, all the answers in ln too. But when you're supposed to use ln, like if you're seeing the Euler's number, e is 2.71 something. If once you see that number, ln for that. Also, as you would drop in any other CSEC maths paper one. I don't know what you're talking about. I don't know what you're talking about, buddy. A for 7. An athlete can run around a completely circular track of 400 meters at an average speed of 5 meters per second. What is the angular velocity? How does this look again? Angular velocity is equal to no, v is equal to omega. So we have this speed. We need to get r. They give us the circumference. Divide by 2 pi because 2 pi r equals circumference to get r. So r is equal to 400 divided by 2 pi. What is that? 400 divided by 2 pi. You could store that in your calculator for now, 63.6. But all the answers are really different, so 63.6, you must see which one it is. So what are we looking at? Anything to change up here, boys? Boys! 5 divided by 63.6. Alright, 5 divided by 63.6. Yep, we're getting 0.786 or something like that. So this is the 0.07. Yeah. This is it. So this is the formula you're using. You need to know this formula. You also need to know angular velocity is... Angular velocity is just how fast it's changing in angles. So it's like theta divided by time. How fast is going, how fast is changing the angle, how fast is switching that angle. So angular velocity per second omega r is yep, and it must be in radians. Oh gosh, I's a boss. I feeling real good when I remember these things. Yo, Javish, where's the scene? Nice. Bless up, bless up. So some people, this is just easy thing. But for people who, it's not easy thing, blessings. Look thing for you. Boom. Keep in mind, normally the killers in Cape Physics, the killer questions normally come in the paper 2, which you're not going to get. That's the questions where you need to use a little more creative thinking. So you're really losing out some fun and games here because of this situation. All the new people who just drop in, don't forget to close off the live chat, press like, bring back up the live chat. Nice. If anybody don't understand, I know, no feel no how, don't watch no face. Just let me know you don't understand which part you don't understand, and we'll run over. I'll try to explain as best as I can. Remember, I don't teach this in school, so this is based on quick research and a decade-year-old memory of doing this. I did really well in it, and is my thing. But I still pay on that disclaimer, which of the following statements are false. Oh, we get some conflict of answers here. Yes, this is a troublesome question too. I hope I have a correct answer in this. Saying B, D, C, nobody say A. Newton's first law of motion can be used to explain terminal velocity. That is true. That's good. What's Newton's first law? Remains at rest, continues in motion, straight line continues with the same velocity and as a resultant force. So yes. So terminal velocity, no resultant force, yes, great. Newton's second law of motion explains impulse. Newton's second law of motion, I just remember F, M-E. So one force, but there's the 1 Newton is described as the force required to give a mass 1 kilogram, acceleration 1 meters per second squared. But is more to deal with the change in momentum. It changes the momentum, mv minus mu. So it has to do with the change in momentum, which is also talking about impulse. So this one good. This one we'll come back to this one. But that one kind of good too. Impulse. Impulse is what? Ft. What's the formula? mv minus mu. What is that equal to? Be kind of good enough. Be kind of good, right? Because Ft is impulse, force, time by time. Impulse. All of these formulas, decades. Impulse is force by time. Force by time. Nice. Which is equal to mv minus mu. So this pretty good. This pretty good. I would impulse is changing momentum. So yes, nice. I would go with that. So impulse is the change in momentum. And you see, when you're applying the force, this whole Newton law, all you're really saying in layman's terms in Newton's second law, when you get something a resultant force that have weight, that have a mass, it will accelerate in the direction of the force. You would give it momentum based off of the force. And that has to do with more with the impulse than with the F equal ma. So Newton's second law of motion more on this than on that, to be honest. This is more like a derivative of this in my book. Anyhow, so that good. Impulse and momentum have the same units. We just see that Ft is equal to mv minus mu, so that good. Obviously not the, now this is a little tricky though. Impulse, you see impulse have force in it. So if you have a vector in it, if it's a derivative of a vector, it must be a vector too, because it must take into consideration where the force is coming from. So I would go with D. Definitely D is the other one out. So D is the answer. Time is always scalar. Everybody knows time is scalar. So you need to know scalar and vector quantities. Who scalar, who vector. A good idea with these tricky ones is if, as I said, impulse have a, see if the formula has something in it that leads it down a vector route. Like impulse is equal to Ft. Everybody knows force is a vector. Force important to know the directions. So therefore, impulse had to be a vector too. Can't be just, his father can't be a vector and he just living his scalar life. He had to be a vector too. Alright, so let me go to the next question. Nine. So my aim is hopefully I can get like 50 questions done between now and tomorrow. I'll try to pick as general and repetitive themes as possible. The longest thing is taking me to just come up with good questions that covering what is usually brought. Especially like since I'm not watching these questions already. From now on, if anybody has to pass me by, just tell them 2021. This is, or tell them the 2020 July. This is 2020 July. So from the future, which of the following, this is Wednesday past paper. Which of the following conditions best describe the conditions for static equilibrium? This is the next kind of hotter question too. Yes, I don't really know where's the answer for this question. Somebody has said, see that all forces. Now torque is the same as like to deal with momentum, so that's good. Moments are equal to 0, that's good. See that all forces? Like that phrase all forces. Now, if it was like that alone, I'd say cool. But now they say net external forces, we're sounding way better than all forces. So this is a question I would lay on, go to your physics teacher with. I would lean towards B in this case. Now if I had no B, I would go with A. The reason I'm not picking C and D is because they're halfway. Basically, these conditions of static equilibrium is that the upward forces must be equal to the downward forces. Otherwise, it will start going up or it will start going down. So it must have no resultant force acting on the system. No external resultant force. All the net external forces must be equal to 0. And the next part of it is that the anti-clockwise movements must be equal to the total clockwise movements. Or you can say net torque. Torque dealing with movements. Perpendicular force, distance, Fd, torque. Torque. What's the thing that is up in up here? Like up here. The teacher say B? Alright. So this one a little iffy. I would tell you to go to your teachers with this one. So you can see a question. Students send me questions with like real close on these things, but so I make back one. So all forces, net external forces. Sometimes it's all forces. Like if this not here, well obviously it's A. But like if you see net external forces, iffy. B. B is the answer I will hold on for now. But at least you know the two conditions if the question comes straightforward. Sometimes you will see correct answers. Like that question have 4 correct answers, but it have like the most correct answer in that question. All the answers are correct. All of them are conditions really. Here comes Lasso. So Lasso jumped off a cliff, 58.8 meters, a new world record, into a pool below. What was his speed just before he hit the water? By the way, there was really a person named Lasso jumping off a cliff that was exactly 58.8 meters. And it was really a new world record. That is when it's like 3 o'clock in the night and you have nothing to do and you're just making up questions and things. Yeah, so what was the speed just before he hit the water? Which one, boy? So this going into motion laws now. How many questions are doing? I'm doing as much as I could, like between now and I don't know. I have a next live to do 10:30 and I want to sleep because I ain't sleeping a long time. Not a CXC paper. Ting, 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 ting. So the new people who just come in, this is a free session, but you have to pay. The only thing you have to pay is press the like button and try and share to whatever social media. You can't, if you're on social media. Being on social media now is, I mean, you have a good control to be on social media now. At least, delete it from your phone while you're studying, or turn off your phone while you're studying, that kind of thing. Because it's real addictive. Everybody saying deal. Lasso doing everything. Yeah, I was going to name everybody Lasso in all the questions in it. But I said I must stop Papi showing questions. Lasso jumped off a cliff 58.8. His speed just before. So we want speed. We have distance. Is it? We have acceleration. V squared equal to square V squared equal U squared plus 2AS. Nice, nice. Because the initial speed was 0. Because he jumped off the cliff, right? Or I should say walk off, he didn't jump off. He just I doubt Lasso that want to jump up in the air and get some more height to get some more speed. So I think he just walked off the cliff, right? 0 plus 2, 9.81. So at the start of the paper, they decided to use G as 9.81. Am I correct? 58, like back in the days they decided to use 10, but now keep 9.81. V squared is equal to that, so you just get the square root of 2, square root 2. I doubt I need to bring up calculator and they know how to do them thing, right? 58.8. Well, really the last answer was D. So I get 33.9, which is like D. This is assuming that you don't reach let's call it terminal velocity, no drag, none of them kind of thing. You just falling right, just increasing speed with that A right through, nothing happening other than that. Nice. Something else I was going to add with this. So yeah, you need to know your motion laws. How I used to remember it is all of them stem out of two things. One is acceleration. So after a while, it's just remember all, like for me, I just remember all. But if I ever need to bring it back, what's acceleration? Rate of change of speed. So V minus U over T. And the next one stems out of the distance. Distance, or like speed is distance over time. Not speed, I'm saying speed, but velocity, distance over time. And we use average velocity here. Just again, the U and V now. So this is where you're going to be is equal to U plus AT. If I change this to A, make V this, this is V plus U over 2 is equal to S over T. I hope I'm writing here. VT, UT, S, yeah. And this will lead you down to the other roads here. Average velocity, distance, time taken. Everybody get hit down with a T. UT plus half AT squared. Nice. So to get any one of the equations, and the equations are like v is equal to u plus at. You have v squared is equal to u squared plus 2as. You have s is equal to ut plus half at squared, or equal to vt minus half at squared. To get any one of these equations, you're using those equations to help you figure it out. So make sure you know all your motion. I don't know if they give you these equations, they give you them at the start of the paper. I doubt. Or they shouldn't. I mean, if they're giving you that, I really keep paper. What? What number are we on? 11? Let's get the answers. 11. There's masses on both sides. What are you talking about, Ben? Physics don't give no equations? No, right, great. Somebody lost? If they lost, let me know where you lost. Or somebody want to use MGH? Yeah, you could use MGH too. The mass will cancel out. Yeah, correct. But which one do you find was faster? I find like this was faster, boy. It's the same thing. You end up with the same thing squared from the kinetic energy. Not bad. Not bad. Not bad at all. E. So everybody will know A for this one. Which equation can be used to determine time for the object in the diagram be able to reach the ground? What? Time, we have initial, we have acceleration, we do have the final velocity, we have distance. So ut plus half at squared. That's what we're using out here. 10 is equal to, oh, and also you have 20 coming from the 20 will stay on the top, divide by the the A is the G, right? So remember the U is 0, so 0 plus, since the U is 0, initial velocity is 0 in these kind of situations where you drop it. I show in this exam, since my time you must access something with a ball or something must drop from somewhere, somebody must jump over a cliff, something must fall out a plane, a parachute that must fly. So make sure you understand these things, right? Something must drop in this exam. So 0 is always the initial velocity in this situation. Half g, this was at squared is what we're trying to find. So rearranging this 20 divided by g square root to get out the squared, t is the answer. Nice, nice, nice. Great. Now let's look at number 12. Shout out to the Wilmer's crew on the inside. Apparently it have a spot from Jamaica inside. From Wilmer's. What school you're from? Let me know what school you're from across the Caribbean. Just say your school and your country if you don't want to big up your school. If you find, nah, no ranking for my school. Just shout out your country, big out your shout out what country you're from. Like is the whole of Wilmer's inside here. Wilmer's, I hope I'm ready for the exam. I hope I'm pronouncing that correctly. Is Wilmer's or Wilmer's? What is really called at the school? Just Wilmer's, just so? Which are the equations below oops, can be used to determine impulse. So our next impulse momentum business. This is the actual formula for impulse. This is cake. Don't put that T there. We know that T there, that's foolishness. If you put the F there by himself, yeah, that's good, but nah. So nah. 1 and 3 only. C. So we talk about this already. CSEC, St. Vincent, Dominica, Jamaica, Cedar Grove. I just take another time to check out the countries: St. Vincent, St. Lucia, Trinidad, Queen's Royal College, Barbados. No, Queen's College, Barbados. Jamaica, Wolmer's Campion. The whole of Jamaica inside there, big up Andrews. See, Wolmer's C. Let's do another question. Feel like I could do physics. I don't find physics nice. Physics like it was stress, you know. Just normal thing. Either you know or you don't know. And if you don't know, you just find out and then you know. Let me get answer for number 13. Cuba is I go back now. Alright, you can get next admin day. Jamaica College. That's something called Jamaica College. Are you going to name all your school after the whole of Jamaica? Green Island, Jamaica, Queens Jamaica, Tobago, your Castle High Jamaica, St. George's College Jamaica. But how all your school have, hey, pressure gunners. Big up yourself, Chad Hussein. Come from a very big school. Eh? Somebody from Bombay, IIT. Big names. All the way from Bombay. Look at some answers. This Avogadro's number is equal to what? Okay, this was 3 marks. Just make sure you don't mess up the units here. It's 12 grams, but we not see nothing. Oh, I went on for 2 at the same answers here. Oh yeah, this is sleepiness. Alright. But how they'll bring this question, they'll mix up the kilograms and grams. What else they will do? They might say instead of atoms, they might say compound molecules or something. That is it. But wait now. A and B is the same thing. This is more Z's here at a copy and paste. What? I'll tell you how that happened. Eh? I'm making up the question and I just copy and paste everything and I'm coming back to change the answers to like what I think they'll normally bring, and I just forget. I just went on to the next question. So A or B. If this case happens in CSEC, all you know what to do. A or B. Alright, let's get the answer for number 14. We're all doing well-ish so far. I mean, there's 300 and something people here, right? 398. We hit the 400. I wonder if we hit the 400. And I really only seen comments from like about 40 people. So, answers that is. So I don't know if some people in the background like, damn, I know nothing. Rate how much you know so far. Rate how much you know, how much you feel you have done in physics. Physics is Wednesday, anyway, just putting that out there. Rate it out of 10. Oh, A and B is not the same? Oh, great. That, I underestimated myself, man. Look at that. So which one it is? It's not A. Look at that. I put kilograms here, right. So you see, I beat back my own self in this. You're looking at 12 grams or 0.012 multiply by 1,000, yeah. Kilograms. Why is in the chat if you understand that? Mass in kilograms. Thanks people, thanks. Man tired. Yeah. If I read so tired, you just get a boost of energy. That happened to me this evening. That's be the dangerous thing though, like when you're in sleep and your body say, alright, here's some energy. That mean if you overdo that, you're going to crash very bad in a day or two. So that's why I know I need to get a little sleep before I do that live. Oh, it's Tuesday. Sorry, physics is Tuesday. Physics is Tuesday. Anybody who sort of say when the physics is Tuesday, don't miss your exam, please. I need to make sure I write any comments afterwards. Like say, so say physics is Wednesday. So that job of the day. Love your videos. Blessings. I'm waiting for answers for number 14. What is the equation for this soldier boy? Gravitational field strength. There's gravitational, there's the one with the two masses, and you're always multiplying by the distance between squared, and it have a constant, the gravitational constant. I don't think I'm missing out anything else. But if you're doing the field strength, you're removing one of the masses. You just have the mass by itself of the Earth, and you still have the radius squared. Correct me if I'm wrong, this is the formula that I'm using. But you're taking all the other mass, Elena, because you're just working on the gravitational field strength, right? So you divide. I need a book, I need a textbook with some good thing here, man. I'll divide, review off our notes. I know gravitational field strength. Yeah, right formula? Cool. So this is the gravitational field strength. And alright, so how are we doing this now, boy? Yeah, hitting them a quarter of the radius. And half of the mass. Right, this is a common question. You can bring down the mass, any fraction, bring down the radius, any fraction, you need to know what to do. So the current answer right now is G. That is what I will do. I will say G is the current answer. The present field strength is G. They set that as G, equal to Gm over R squared. And I want to find what the new field strength will be. New G. New G, what will you be? So the new G is like the same old G, but half of the mass. Which means, so like if I'm doing half of the mass here, this is just like equation games here playing here. Half of the mass means I multiply by half. It means that new G will get multiplied by 2. If I bring across the half, because the mass on top, right? That making sense? 2G. I'll do it another way, but I'm just doing it this way for those who will catch it this way. And R, new R will be, what is the fraction? A quarter. A quarter of the present. So a quarter R to be squared. This one needs to be squared. A quarter of the radius, all to be squared. That is the trick in this one. That is the trick in this question. So this is really R squared. I'm doing all kind of ridiculousness here. This is really R squared over 16. Are you with me there? Are you with me? R squared over 16. This is really like saying you're dividing by R squared over 16, which is like multiplying by 16 over R squared. So this R squared could tuck back in himself there, and we need to get this 16 across here, so it will divide, whaps, so you get 1 over 8 G B. B. Why is in the chat if you understand that? was a kind of poor explanation. If I must say so myself. If I was teaching physics right through, the explanation would be clean on the first go, right? But that's how I would do it, like if I had to do this exam here. Let me see if I can come up with something a little better. Go over so. Ting, 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 ting. No answer there, Batman. 16. No, 2 over 16. 1 over 8. I feel like B is the answer. I'll double check again. So, well, let's say the formula was GM, so the gravitational constant, right? Field constant. We don't really care about the constant. That constant will remain the same. Divided by R squared is equal to G. They told us is G. So we're trying to find what the new gravitational field strength will be if we half the mass. Let's do that. Let's go on ahead and half that mass, and we square get 1/4 of the radius. I don't know why I'm blanking out. 1/4 of the radius. So this is the new radius. So you're squaring this. You are not squaring this. That just so. So what I'm essentially going to do is organize myself so that I will get back that. Understand? So that I can get back that, so I can get new gravitational field strength in terms of G. Where did 16 come from? When you square this. So just make back this the subject of the formula again. Get rid of all the unnecessaries. This 2, dividing so it will multiply. Get rid of the 16 here. It dividing so it will multiply. So 2, 1, 8, 1, 8. 1, 8. And let me see if that makes sense. It gets smaller. Yes, 1, 8. The thing is, the radius related in a square relationship. The radius. So enough for that. Just I out. Just understand how to plug in the question and how to swing it back. I guess you can watch it over. People saying understand. I feel like I explain it in a way that everybody can understand, but maybe you might have to watch it over. I don't already have a better explanation right now. So since my days they're asking you questions on geo, they are asking you questions on geostationary satellites since the beginning of time. And it doesn't matter what they say in the other answers, one answer here is always correct. Yeah, the reason I put back the old G is because this is the new G. I just put it back so I can make it. I just put it back so I can make it. Alright. Let's see if I can figure out a better way to explain this. G1. Alright, I have the better explanation here. Let me put the new G. Cool. So this is G is equal to M. I hope this works. R squared. So the new G, hey boy, let me give you a 2 or something, right? G2 would be equal to G over the M divided by 2 over R squared. What's the new R? 1/4 of the last R, right? So like R and 4, so B squared. Yeah, this is making more sense for like somebody to follow who understands substitution. And now I'm going to pull out this, and I'll end up with a factor here. And what's going to happen, right? This is going to be like 1 over 2 GM, and R squared over 4 is the same as R over 4 to B squared is the same as R squared over 16. So since I'm dividing by 16, it means I'm really, let me just show you how I do this in like an exam. This means divided. So in the end, when I flip this, it will be like I multiply by 16, the r squared will go back in its spot. So when you have like a double fraction, 2 vinculums, whatever it's called, a line in the fraction, the one underneath come like a multiply now. So you have a 16 on top. So it's like 16. If you pull out all the numbers here, you have 16 over 2 multiplied by GMR squared. But what we know GMR squared to be, this is the new G. What we know GMR squared to be, the old G, G1, first G. So this is 16 over 2 times G. This is giving me a different answer times the old G. Is this correct? G1 with the 8. What would the new gravitational field strength be? I think I confused the situation more. Okay, I like to tell me what I'm doing wrong. Present field, what would the new, because it would need to be less mass, half. G2 is that. But I find like this making sense. Exactly why I say 8G. But I find like this making sense mathematically, but it's not making sense in any other way. Let me just take 2 minutes on this question and just figure it out. I still think the answer is B for reasons, right? If the Earth lost half its mass and its radius became quarter of the present radius, what would the new gravitational field strength be? G1 is that. G2 is less. I do something wrong here. Skip this. If I do it, I do it. It's making sense. It will be ratio, I think. It will get bigger. How it will get bigger if the gravitation, if the mass gets smaller and the radius gets smaller? I mean, general, just move on now. So 2 is supposed to be on top. Yeah, maybe I just do something wrong. Let me just check this. So this is GM on 2 divided by no, I feel like this real good. Alright, we'll come back to this question. We'll come back. So 16 and 2 are going to go over to the G2 and divide. Yes, that's correct. But they ask us what would the new gravitational field strength be, which is this. So it will be a fraction of the old gravitational field strength. Something real simple that just missing here now. Maybe I would have been able to come on now, sir, because you just decrease by 4 squared, so it will get bigger. Or maybe it does get bigger. Maybe it is 8G. I'm going at 8G. This makes sense. Who said that? So I'm going to change this answer to 8G and we're going to D. Good thing I come back to this question now. I'm not moving on. We have to get correct. 8G should be the answer, so I think they made an error. 8G. We always sticking with 8G. Because, let me just examine this one more time. It lost half its mass, but the radius went down a quarter. Right. So although it became smaller, the radius went down way smaller than the mass. So it became more dense. So gravitational field strength became more possible. Alright, Talia. Well done. 8G. So I get one wrong in the probably would not get one wrong. If I come back and check it over, I'd fight up and say, well, 8G had the answer. Although I didn't have 8G here, but I'm supposed to have 8G here. Right? So why is it in the chat if you understand that? I was doing it in inverse by not setting up the new G as a fraction of the old G. The R increased exponentially, it affected the result more than the mass. That's correct, Amaris. And it's not necessary that the smaller object have a smaller force, is that it more, because this is the formula now. So if the mass decrease but the radius decrease more than the mass, this will become smaller. And you know what happens to denominators? What happens to the answer if the denominator gets smaller? It gets larger. So in other words, it's telling you like a more dense object will have a higher field strength. Alright, enough time on this question for you now. Alright, we can move along now. So the answer for 15. Try using numbers. Yeah, you can use numbers in the two equation and see and verify. But here we beat out that question enough. 8G it is. 8G it is. And you go back and watch back what I do there. I just learned back a piece of physics there. So some people still on the G on the 8 side. I will definitely take that question, modify it and post it on my Instagram and talk to the teacher and think about it. Has the same angular velocity as H, right? So anytime you see this question, just ignore your answers the same. They'll ask you about a geostationary satellite, the rule, same angular velocity. Because you have the Earth here and you have the satellite there so. Whatever position it's watching here, let me say it on Trinidad. Well, I'm not really looking Trinidadish. Right, let me see on Trinidad thereabouts, right? And geostationary means that however this thing, or however the angular velocity of the Earth, that the Earth is spinning, that satellite will be matching that same angular velocity. Obviously, the satellite will be moving faster than you on the surface of the Earth. You understand? But the angular velocity is the same. Even if it was quite out here, the angular velocity would still be the same to map the same spot that in a fork. Next question. A grinder can nice. That question, boy, that Earth question catch me off that day. What the Earth doing half in it mass and all kind of ridiculousness. A grinder can generate power of 8 kilowatts for 100 seconds. If the grinder uses an input energy of 1, these kind of questions still come? Or you still get questions like this in Unit 1? Just verify for me. Right? A grinder can generate power of 8 kilowatts power energy time. The grinder uses an input 1000 kilojoules equal. Oh, you're not doing an equal thing here. You're doing a percentage thing. So alright, so you have the 1000 kilojoules by himself like the kilojoules, a million joules on it. Million joules out here. And 8 kilowatts, so energy P power by time. So 8 kilowatts by 800,000. 80% using 20% lost as heat B. Right? 800 over 1 million. Guys in chat, if you understand that. Vibes and more vibes. I never knew it had so much people in Cape Physics. Never knew. I thought it would be 100 people in the line, but apparently our exam is like Tuesday. Wise in the chat if you understand that. Oh yes. So that's a little power near work can that question could just as easily pop in CSEC. Yes, so you still have questions like that, it's okay. That would be out of the way if you walk in Tuesday and you see back Frank here and Lasso and the line up on lawyers and start a gangster CSEC the way these gangster people. Frankie pushes a box with a uniform acceleration across the room with a force of 9 newtons. The box is weighed and found to have a mass of what? What is the acceleration? Is that F equal to MA question? Is this a F is equal to MA? I think it is. Just watch out. Anytime you bring one of this, they must somebody say to redo this one. Well, the formula that I use for this is power is always the rate energy is transferred, the rate of doing work, energy over time, whether you're dealing with electricity, whether you're dealing with pushing boxes or whatever, power, energy over time. So power is measured in watts. The SI unit for power is watts, so that kilowatts, there's a problem, so I just change that to 8,000 watts one time. This is a problem too, so I just change that to a million joules one time, or can I just stick to kilowatts and kilo? Well, I change it to watts and joules, and so I found out that the energy that it generating was power by time, so that turned out to be 800,000. But the energy that coming in was, energy in was 1 million. So energy loss was 20%, 200,000 over. This one across the room with a force of 9 newtons, the box is weighed and found to have a mass. Not doing K physics, doing the CSEC physics. You'll get an A for this. Have you got MA? Mass is in what? kg or G? Is the SI unit for mass on there? kg, right? I mean, that's the first thing they teach you. So, F equal MA, so you do it at 9 over 5.4. Well, everybody get here the answer. Next question. Which of these statements below is true? So what year is this? This is actually a future paper from 2021. Which of the statements below is true? In elastic collision, kinetic energy and momentum is So I feel like I see this question here. In elastic collision, kinetic energy is conserved, but momentum is not conserved. But it's working though. Are you working again? I know typing comment back all kind of thing. Live chat. I need to see what's going on in live chat though. Welcome back, welcome back. Nice. Good thing I didn't go and reset the whole internet and think. Momentum is always conserved, but kinetic energy is not conserved. Both in elastic energy. So in elastic, kinetic energy is not conserved. In an explosion, kinetic energy is conserved and momentum. I think like the best answer is A. At the end of the day, kinetic energy, that was not right. Kinetic energy is never really truly conserved 100%. But the best answer is A here. In elastic, kinetic, once you see in elastic, no kinetic energy conserved. In an explosion has no kinetic energy to start with. Before the explosion, it have no kinetic energy at the start of an explosion. Except maybe to throw the grenade. If it's a grenade and you throw it. But other than that, no kinetic energy at the start of the thing. Just make sure I press like on the video there. So we lost a set of people on the live just now. So A is the best answer. And 19 was the people saying 19 here already. Let me see if I can bring up 19 one time. I need to stop giving all the peaks of the other thing. All the jumping the gun. 19. Alright, so 19 is another question that I'm accustomed to seeing and another kind of thing that they testing people and people too since my days. Keep clicking the wrong thing. Ooh, I just get a feeling of hungriness. I wonder who open now, eh? All the way I don't hurry up and finish this session so I can go and eat. Momentum is always conserved, that's correct. Ooh, some of them slang they are struggling to keep up. My wife I get entangled. It was an entanglement. The parachutists, I should already name this live entanglement with physics unit 1. The parachutists in the diagram, terminal velocity, this plus that must be equal to that. They don't get that. Okay, that's some really easy questions in the dance. Make sure you have them in easy questions down. I keep clicking the wrong thing. So, tougher questions start to come with like simple harmonic motion when you're going, and then when you're going to eye, when you're going to lens. The ending of the paper I think is definitely harder, would definitely be harder for students than the beginning. What's the ending module 3? What's the topics in module 3 again? I don't have it off the tip of my tongue. A body has a momentum of, okay, momentum is P, and a mass of M. Its kinetic energy is momentum mv equal to P and a mass of M, right? It's kinetic energy half mv squared. So it's like mv, if I square that, I need to divide back by the m. Put that 2 on the underneath. I hope I'm doing this one correct this time. Throwing the p inside there. Anybody resembling that one? P squared and 2m. C? I'll get that answer. C. Thermodynamics thermometers. Thermo, yeah, thermo. Zoop, zap. Are they still get everything too? Yes, get. Or is that engineering? Thermodynamics, I remember. C. So, yeah. So, what I do here, boy? What did I do? Just play around with the equation a little bit. So, the momentum is mv. And kinetic energy is half mv squared. Half mv squared. So I need to make the squared too. So in other words, half mv to be squared. This is not kinetic energy, but to make it back kinetic energy, divide off by the m, so that the m will cancel that m end up squaring, just to make it so that and I bring down this 2. I guess that's the fastest way I think to do this. You could obviously go the long route of actually substituting each into each. I think that's good enough. If you're doing Cape for physics, you must understand that little Jedi mind trick. Alright. Next question. More moments. So I'm hoping against hope that I can come through tomorrow and just finish up, clean up thermodynamics, everything. But it's going to be a long night, so I'll probably have to prepare that in the morning. Ajani, Brian. Well, I am a math teacher, but I mean everything that I do here legit. Except the good half question, and now 100% as that. Show on that. And any physics course in D. How many questions tonight? Well, I'm trying to do like 25 to 30 questions tonight. The diagram below shows the forces acting on a bridge, on a drawbridge in equilibrium, which equations can be used to describe the, everybody saying D, 1, 3, and 4. In equilibrium, upward forces equal downward forces, good? Something missing from it? Two looking, something wrong with 2. PA by FB about this point must be equal to, right, so that's good. This is our next moment, say. And this one, let's see what we know, this one. PA plus B, right, so about this point, equal to WB, that's good. So 1, 3, and 4, D, so everybody who's saying D, D nice. Somebody get time out here, see? Johnny Bryan, who's any cool? My admin's looking out here, boy. Alright. Why isn't it that if you understand that, then you move on? So you will get a question, something like this, they should give you something like this, or at least with a system. Some kind of moments question that, and they say, and they're basically using the law for the equilibrium. Or they could give you to find the missing force, like the physics style question. And you just use the laws again to solve it. I don't think you should get problems with that. Let me do our next question. I have to take a little peep at the chat. Explain part 3. Ooh, alright, I need to close off this and bring it back up because it's tripping off. This one, PA is equal to FP. About any point, you know. So, PA, the moment about this point is equal to they must be equal, it's in equilibrium. Anti-clockwise equal clockwise moments about that W. It's about any point, That's how it in life. Don't fight now, don't fight. What is the tension? T in the ropes supporting the log below. Right. Right. Now you see we could get somebody say explain 4 now. Explain 4. 4 is the same thing. Moments, you all know how to get moments is the force by the perpendicular, the distance by the perpendicular force, same thing. So this distance is A plus B by this force must be equal to W by, did I say force? By this distance, B. So P by A plus B must be equal to W by B. So it's a force and a distance, a length. People saying C, B, B, C or B. I hope I have a correct answer for this. Don't kill me if I don't have a correct answer by going to work it out now. What you want to do is realize that you want the vertical component of this force. Because the horizontals cancel themselves out. So forget about the horizontal. So you want the vertical component of this force. So we call that F1 and F2. It don't matter, F1 and F1, because both of them is the same force. Right? Cool. So I just need to find, like, for 1, what is the tension in the ropes? Or I'm trying to find the tension, but I should identify. So F1 will have to be like 3,500. Why am I saying that? Because upward forces must be equal to downward forces. So this is half. Why is in chat if you understand that? So now it's just a little triangle question here now. 3,500, 60 here. So this is like 30 here then. It don't matter, however we want to do, or whatever floats your boat in this. And you're trying to find the hypotenuse, so you use cos. So adjacent hypotenuse is here, underneath thing, cos 30. So the answer is 3,500. The cos 30 of that. Find this, and this looking a little suspect. 3,500. Trying to find that. This is 30. It will be more. So cos 30 equal adjacent over hypotenuse, or divided, right? So 3,500 divided by cos 30. Or the reason is because if I had to keep the 60 at the multiplier. Right, cool. What answer you'll get there? 3,500 divided by cos 30. So just make sure your calculator switch back into degrees when it's supposed to be in degrees and radians when it's supposed to be in radians. I'm getting C. Why is in the chat if you understand that? I forgot to check how much you all rate it. So some people lose 7,000. Yeah, that'll be 3,500. I feel like it must be about answer there for 7,000. Because I know when I make this question, I would put the answer if you do the 7,000. You see, that's be the hardest thing with making these questions, putting in trick answers. So C for correct. Some other question I was going to ask. You all rate the, how much you all know in physics again for me, please? If you can, like, rate how much you know in physics unit 1 out of 10. 10 out of 10 mean scholarship level. 0 out of 10 mean getting a 6 or some kind of thing. Your SB and then when I get marks for your internal assessment. Which of the following quantity has no dimensions? 7 out of 10 negative. Everybody has 7. Cool, it is part of the reason I pass CSEC physics. I hope I could bring it through for the Cape physics too, bro. At least get a good push. Because I mean, one long session and going and help if you wasn't doing anything throughout the whole year. 9 out of 10. B is an easy question. Which are the following? Oh yeah, I feel like they're asking this for the every year for the rest. your children will not get this question, so make sure they don't get it wrong. This have units that dimension, this refractive index is just like a number 0.45. Alright. When I'm tired, I say alright, play. Die mosquito, die. How long I'm trying to kill that mosquito? Since he started the live, that mosquito flying around me. Somebody asks what is dimensions, and the answer that person did, that's a little scary. A ball is pushed down a slope as shown in the diagram below. At which point will it have the most kinetic energy? Answers. B. The lower it is, more kinetic energy. Higher it is, the more potential energy. Unless like it go down low and then it relax for a long while down there, right? Some people will say the air because it's looking steeper, but no, B. By the time you reach back over again for the next time, you bring your partner. So B is the answer, very simple. We lost some energy now. Alright, this is a question that they asked me a long time. Note that this kind of question always comes. They will always ask you something like this. Make sure you have this in your back pocket. Give me the answer for this question. All you know is to draw this graph. Draw them graphs then. With zero sleep in your system. In the middle of the night, 4 o'clock. Because just to be safe, even questions that I know is repeat and thing, and even questions that I just make sure and write out and do all my questions to myself. Just so nobody can be on my case and say I'm posting them questions. So when are you doing CSEC physics? I don't even know yet. Everybody's saying that's T. That should be K. That's K, right? K. So are they seeing some evidence or some? No, so EK. Alright, so the total is this one. So hit me the answer here. As you go to the middle, so as it swing down to the middle, you have the most kinetic energy at the middle. So most kinetic energy at the middle. So yes, this is A is correct. Most potential energy will be at the upswings, the heights. Let's have a next one to it. Acceleration, the graph. All the graphs in simple harmonic motion. All the graph in simple harmonic motion. Just go in your textbook and just learn all them graphs. So you can just know which graphs you're supposed to. This graph, you have the graphic acceleration, graphic what is happening with velocity, everything. Just learn all them graphs. They can test you on any one of them. And I think this is like the most important one. This is the most important graph. So textbook note, wherever you learn physics from, your uncle, brother, sister, just make sure that they tell you all the graphs. Simple harmonic motion. This question can't fit pressure. Not too sure about the answer to this question. I make this question knowing that my knowledge on this topic not on a full 100 right now. Let me get the question and then the thing. So here they do an experiment. This is the amplitude. This is the natural frequency of the system. And there's be force in different frequencies. But obviously when you force frequency around the natural frequency, you'll get the best frequency response. You'll get the highest amplitude. We know that. I know that. You should know that. And then they will give you something like some dampening solution or lack of damping. Damping or dampening is the word they use. Wherever that word, solution, situation, And in this case, lowest pressure indicates less dampening. When you dampen, it's normally get like this. So if you go less, if I deal, all I want to say, this is tricky. This question is dumb. Okay, it is a dumb question, but it's a dumb one mark you want to collect. The answer is A, as that is the least frictional force and therefore the highest amplitude. That's a good answer as well. That's why I see this question tricky, because but here it seems like amplitude raise as well. This is a question I want you all to take back to your physics teacher, somebody who doing physics all the time, if you trust your physics teacher, because to me, both of these answers can work. Have some, and this answer to me seems a little more legitimate. I'm going against the flow and saying D, and here's my reason. In this answer, it seems like amplitude went up a little, and because the situation is, when you're dampening something, I just know this from the graph, when you're dampening something, it's the frequency of the system, the natural frequency of the system drops. So, tricky question. Obviously it's not B and C. It's not going to remain the same, it's not going to drop off like that. So, no, A all the way. My teacher done, I'm not going to read some of them comments. All this, you mustn't get on people for getting wrong answers. Having a wrong answer it means you're trying. So everybody's still saying A. The system wasn't changed, so the natural frequency wouldn't. I never said the natural frequency of the system changed. The natural frequency, on your hold on it. I feel food going and get to come to me. Let me just, I'll hold on 5 seconds there. I just want to make sure food comes to me. Sorry about that. Alright, Alright, people quarreling with each other, ting, still in our church. Is it? No. Yes. Our Baptist church there, and every Sunday they start up and it's be reaction. All you need to know, this kind of Baptist church do not play. And then we'll go until 11 o'clock. Anyhow, so because to me these saying since the lower the pressure the system is oscillating, its natural frequency increase. No, it just means so I just thinking about it logically. And remember, I'm not thinking about it from a learned physics. I know this all the time, every day I teach in this perspective. I'm thinking about it. You put this oscillating thing in a system that has less pressure, the dampening effects will go down, right? So yes, the amplitude should go up. But when you dampen something, the frequency which it would resonate at drops. You can check all your graph, all everywhere. When you dampen something, the frequency which it resonates at drops. So that's why all the graphs and them just do this. So if you put it in a system that the dampening effects is less, low pressure, the lowest pressure, it means that the frequency that it will resonate at should go up, but the natural frequency still remains the same. Still have the F0 here, but it's normally called this one F1 if I'm not mistaken. Earlier I'm not too up to date in the things, but it's called this F1 and like F2 and things. So that is why I would shade D, but I find A still suspect. So I'll leave the answer like asterisk. So, alright. Next thing. Next question. Well, yeah, we had to finish soon. We have how much more to make 30? Once I do like 50 questions between 2 days, I sure knocking off like about 20 topics that is usually come. Maybe even 40 topics that is usually come. Determine the velocity of the wave shown in the diagram below. This is the next question that I do myself from back in 2008 or some kind of thing. Yes, we get these kind of things, right? 2000. When I do this exam, 2006 I think is when I do this exam. They will always give you a question with time against amplitude. Well, amplitude against time, amplitude against distance. So you get in your wavelength here and you get in your period here, and then they ask in your velocity. Sometimes you get the frequency, anything from this. You could ask anything from this. So what we want, the velocity is lambda f or lambda 1 and t. Yeah, correct me if I'm wrong. So just the thing I need to make sure with this is I do a full wave. So a full phase, a full wave, a full 2 pi. So this should be 4. Whatever it is, you just multiply up. Or they could give you like this as like 1. You understand? Pay attention. It can give you like this like 3. So then the whole thing will be 3, 6, 9, 12. You're trying to get the whole waveform. And with this one 30. So to bring this 20. That one obvious. 10, 20. So 20 here. 20 and 4. How are we doing this? 20. 4 is the period. So I'm just going to put V. Anything to switch up? Milliseconds. Dirty little people here. So 4 times 10. You always have to be watching out for them, but you're always coming at some kind of conniving tricks here. 4 times 10 to the negative 3 over meters, 20. Yeah, in hertz, right? What are we trying to find? Velocity, meters per second, right? So good. Thought we were trying to find frequency or something. Right, so hit them that answer and while you're getting going. Let me chat and make sure I'm leaving out anything. Nice. 20 over 4 times 10. Only I wish I did the best in exams. I try my best to research all the greatest questions. 5,000. What I do wrong here, boy? 4 by 10 to the 5,000. Well, I will make up this question now. Oh, everybody get 5,000 too. Answer not there. Alright, well I made up the question, I make a mistake. This, well, I just make C5 by 10 to the 3. Why would I make a mistake? Make a mistake. Did I do divided by 2? 2 would give me what? 2.5? 4? 5, 10? I don't know how I make that mistake, but anyway, the answer, you'll catch out to get the answer, right? Let me keep moving, I don't like how I make a mistake in that question. So some more things, they seem to focus a lot on phases and a lot of them kind of little tricks. Even for when they're doing resonance or in pipes and them kind of thing, one end open, one end closed, they'll focus a lot on that. So it made the answer for 28, once I snap 29. How much questions I really put out here, boy? I'll do more than 30, so we'll do a little more than 30. How long will it take? Not too long, right? Same marathon, but it wasn't 2 marathon because I split it into 2. Are the 3 other questions waiting on ice for us? iPad freeze all kind of thing. The phase difference from A to B. Phase difference from A to B is phase. This is 2 pi. This is 3 pi and 2. The way how you can do this is just remember every little section is pi and 2, like the 90 degrees now. Pi and 2, pi and 2, pi. So 1 pi and 2, 2 pi and 2 is pi, that is 180 degrees. Then 3 pi and 2, that's where we at here, 3 pi and 2. They could do this anyhow, they could bring the A up here and bring something quite down here somewhere. So just counting pi and 2, that's 1 pi and 2, 2 pi and 2, 3 pi and 2, 4 pi and 2, 5 pi and 2, 6 pi and 2, 7 pi and 2. If it could cancel out, it could cancel out. Normally when you have even numbers, you get a nice thing. Anyhow, people seem to understand that really good, so we can move forward with real life. Ting, 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 ting. Sound intensity. Alright, so this is something that I know is always tested as well. Always going to ask you if sound intensity is directly proportional to sound. Oh, next thing is actually too, it's also directly proportional to the square of the distance too. Just verify that in the chat for me. It's also directly proportional to, it's proportional to the distance, either to the square of the distance or the distance. I think it's the distance square. Everything with to deal with objects away from each other is now maybe distance square. Right, so there's something that's asked you. And we'll also ask you relationship between intensity and decibels. I did not put that question, I didn't put a question like that, I don't think so. Because remember it related in a log. The relationship is logs. Alright, so this free answer for you is always going to be amplitude squared. That's just like straight out of the textbook there. That's a freebie. And last 2 questions I have for tonight, and hopefully I can see you tomorrow around the same, no I cannot see you tomorrow around the same time. I have a class from 7, so maybe a little earlier in the afternoon now. I'll try not to do it late so that I can sleep when I don't want to sleep now. Exam will be on Tuesday. Intensity is inversely proportional to distance squared. That's correct. That's it. I'll just miss the word inversely. Directly proportional to amplitude squared, inversely proportional to distance squared. Or you're just visualizing that food. Oh, go on. Which of the following is correct for number 30? Everybody saying C. Everybody know this since form 2 and 31. Which of the following what is the fundamental frequency? It has formulas for this, but I just, since my school is, I just kind of try and figure it out. What's the fundamental frequency of the waveform? So you're trying to find frequency, not lambda, frequency of the waveform 150, right? So they'll give you the length of the pipe and they'll give you the speed, right? So we know speed, wave speed is f lambda. And the last question, wait on me. They try to leave me and leave me on here. Hey, it's a multiple choice question. My belly making noises. Use the speed of song. Ding ding ding. One says that again by 31A. A. Low cut. Oh, they cutting all the hair for exam. All you have time to go by barber and thing. Where you go with my young mother and say, hit me there. Nah. You want to come back in school looking, you know, like human. That would be so strange just walking back in school uniform. I'll make sure I reach on time and make sure they're ready for this exam. Please. I hope this gives you like a little idea of what you need to strengthen upon. Why am I taking so long with this question? I reach the end and I freeze. So wave speed, we have the wave speed, we want to work out the fundamental frequency. We don't have the wavelength yet, but we could get it. You see these people always with centimeters, right? They will always be with some kind of notationist, so we just change that one time. 1.5 meters, all they look for units. But this is not the full wavelength. A full wave is like that. So the full wave would be like 2 meters. Catch me? Catch that? So I don't normally learn the formula where there's a 3/4 thing and I just, it's normally be some, all these are fundamental, what is called the first and the third and the fifth and them kind of thing. What's the word boy? Somebody will say it in the chat. The first resonance for some, oh yeah, say it in the chat a minute, you know what I'm trying to say. Harmonic. Is the harmonic? Harmonic is the word I'm trying to go for. First harmonic, second harmonic. First overtone. Not nodes. I know nodes. Nodes and antinodes. It was nodes that I was going for. Harmonic, yeah. So you just extend to get one wave, or sometimes you may get more, so you're just trying to figure out what is one wave in between now. Hopefully you're going to be good at that. And now, 2 meters is the wavelength. 2 meters is the wavelength. That's correct. So 2 meters and the frequency and 340. So 340 divided by 2, 170. See? Everybody see? 31C. 170 Hz. My prediction, if it go as it normally go for the years that has passed, you will be seeing these topics that I gave you here, you'll be seeing 70% of these same topics. This is what usually comes to a CAPE physics multiple choice. This is the line of testing that they do. In every subject, there's some areas that like they do not go on because it's hard to generate multiple choice for them. Same thing in pure maths. There's some things that just where to come up with like perfs, hard to come up with solid multiple choice for that. There are some things that will be asked every single exam like this. They will there's just like, I don't know, like padding, I don't know, like they just to fill up the exam. They'll always ask that question, the transverse and longitudinal waves and who is who and like this. There is a next like padding question. These kind of simple harmonic SHM graphs. This, which one has more dimensions, you know, anything that relative, anything that ratio. So boy, we out for now. So you're doing pure maths already. Do a session in pure maths, no? I did a session in pure maths. I did module 1 pure maths, so I'll do 2 more of that. Any other things before I go by? Anything I'm forgetting? You could come back and watch this at high speed. You could watch it at 1.5 speed so that, you know, you can take it in, turn it on for you when you're sleeping. While you're sleeping, I'll be trying to come up with the last 20 questions. If you don't see me tomorrow because I cap out, I couldn't make. I'll definitely try and touch something tomorrow to just cover the rest of physics. Keep in mind, if you do nothing whole year and you think that just watching these 2 videos with me, you feel you get lucky in CSEC and you want to try and get lucky again. All you have to make sure and put down enough work to get through on Tuesday. I can't stress that enough. Don't just sit them and half picked up, come and watch a video on YouTube. Ain't even write nothing, kind of see. You need to practice yourself. Right, and to all the people who this was just like pure revision for you, easy thing, bless them. Till we meet again. Chemistry, I don't know when it's chemistry, but I'm hoping to do a little thing on chemistry. But chemistry is not as easy for me to just come back up with, to just remember that stuff as physics. I talked about that earlier on.